Let's take a look at the next examples. We have the function f is a one-to-one. We have three parts here. First, we want to find its inverse function and check our answer. Then find the domain and range for f and f inverse. And then lastly, we want to graph our original function, its inverse, and the reflection line y is equal to x on the same coordinate grid. So for the graphing component, we're going to use our graphing calculator. So just to help us with time. So let's look at example 6 or question 6. We have f of x is equal to 1 minus 3x. We want to find its inverse. Okay, so to find its inverse, we have here for a one-to-one function f defined by an equation y is equal to f of x. Find the defining equation of the inverse as follows. You may need to replace f of x with y first, and then we may have to place any restrictions on x and y should be considered. So we may come across something where we have to place a restriction on the inverse. So step 1, replace f of x with y. Then we're going to interchange x and y. Then solve for y. And then lastly, step 4, replace y with f inverse of x. So let's go ahead and find or create the inverse of the original function. So we're going to replace y, f of x with y. Then interchange x and y. And let's solve for y. So we're going to subtract 1. We have x minus 1 is equal to negative 3y. Then we're going to divide negative 3 to both sides. And we have y is equal to, and we can write this as two separate fractions. We can say negative 1 over 3 times x, and then this would be plus 1/3. And how I got that is dividing negative 3 into both of those terms and then using our sign rules. So our last step here is replacing y with f inverse of x. And we have here negative 1/3 x plus 1/3. All right, so next is asking us for part A is to check our work. And we will, but we won't be able to do that for every last question, just for the timing of the video. So here is our original function. Here's our inverse function. Let's erase that and write this a little bit better. We have negative 1/3 x plus 1/3. So we want to compose our functions. So this is 1 minus. All right. So we want to see if these two functions are inverses of each other. And then what we're going to do is take our innermost function, our inverse function, and we're going to substitute it into this equation for x. So we're saying 1 minus 3 times, and where we see x, we're going to substitute negative 1/3 x plus 1/3 into this equation. And then let's see if these functions are inverses of each other. Our goal is to have x as the answer. So let's take this negative 3 and distribute. So then that's going to give us 1 plus 3 over 3x, that's going to be reduced. And then negative 3 times 1/3, that gives us negative 3 over 3. That will be reduced. So here we have 1 plus x minus 1 because we're reducing the 3 over 3's. The 1's are going to cancel out. And we have x. So they are inverses of each other. So that was part A of number 6. Part B is asking us to find the domain and range. Now, both of these equations, the inverse and the original equation, they are linear functions because the highest degree to the variable x and y, or our f of x, is 1. Okay, so if we go back to what we started at the beginning, we have a linear function. So because we have a linear function, the domain and range, its interval notation would be from negative infinity to positive infinity. This is part B. Our range will be the same thing. Now, what we're going to do is use our graph to verify that our domain and range is from negative infinity to positive infinity. So here we have a graphing calculator, and let's go to our y equals screen. Okay. And let's go ahead and plug in our numbers here. We have 1 minus 3x and let's go to y sub 2, the next line. And we're going to plug in, this is how we're going to do it. Open parenthesis, -1. Let's put x there, divided by 3, plus 1/3. Press enter to go to y sub 3. We want to draw the reflection line. And we just say y equals 2. We're just going to say x. And then let's graph. The first line is going to graph first, the second next, and then the y equals will be last. Here we go. Okay, so here is our reflection line that I'm pointing to. If we fold it at this reflection line, then these graphs are going to touch. Okay, so your original function and your inverse function, they're going to be mirror images of each other. So there's going to be some symmetry there. So we're just verifying exactly what we have or what we solved algebraically. So there we go. And if you want to see the table of values, go and press second and graph, and you're going to see your table. Your y sub 1 is the first graph, your y sub 2 is the second graph, and we've already talked about the reflection line.